worksheet today, we have a combination of addition, subtraction, multiplication, and division, all with radicals, basically dealing with irrational numbers. And remember, for multiplication and division, it's possible to take some irrational numbers, multiply them or divide them, and you can get rational numbers from those products or those quotients. The only time you'll get a rational number from adding or subtracting two irrationals is if it works out to zero, which will happen for us here in one of our numbers. So we'll just follow our rules. Remember, addition and subtraction is kind of like combining like terms, whereas your multiplication and division, there are different rules for those. So we'll go through the gauntlet here. We'll go 2, 4, 6, and so forth. We'll do all the evens here. So we'll start off with number 2, and we actually start off with two like terms, square root of 20 and square root of 20. We've got two of those. We've got one square root of 20 and another square root of 20. How many do we have total? We have two of them. So I can write this as 2 square root of 20. Now, this may not be completely simplified, so you always want to check and make sure that your radical or your irrational number is broken down completely. So we can break this into square root of 4 and square root of 5. I'm going to start saying radical. Man, I'm having trouble saying square root. Okay, so you could break down radical 4 into radical 2 times radical 2 if you wanted to, or you could just realize that the square root of 4, there you go, square root. Radical 4 comes out to 2. And what we've got here then is 2 times the radical of 5. So 2 times 2 radical 5, or final answer is 4 radical 5, or 4 square root of 5. Okay, so that is number 2. All right, moving on to number 4. We've got a subtraction problem. At first glance, doesn't look like we can combine anything, but after we simplify, I'm sure we'll be able to break this down a little bit. So 45, I'm going to break this down into square root of 9, radical 9, and radical 5. Again, you can break down radical 9 into 2 3s, and just remember that your pairs of 3s would just give you a 3 back, or you can just recognize that the square root of 9 is 3. Okay, so what do we got here? We've got 2 times 3 times the square root of 5. So 2 times 3 times the square root of 5, or 6 square root of 5. Okay, and then we just broke down the square root of 20 on the last example, but again, this was 2 square root of 5 when you break down 20, or you've got 3 times 2 times the square root of 5, or 6 square root of 5. And what do we got here? We've got 6 radical 5 minus 6 radical 5. This is an instance where we do come out to 0, which is the only time you can add or subtract two irrational numbers to get a rational number. Multiplication, division, that's possible in a lot of different areas, but with addition and subtraction, that's the only time that will work. So number 6, cannot simplify 3 radical 3 any further. So I'm going to leave this as is, but I can break down my radical 27. So we'll go radical 9 times radical 3, and we know the square root of 9 is 3. So here we've got 2 times 3 times the square root of 3, or 6 square root of 3 plus 3 square root of 3. So how many radical 3's do we have? We've got 6 of them on the left, 3 on the right. Add them together, we have 9 of them total. So 9 square root of 3, or 9 radical 3. I just keep bouncing back between radical and square root. Just know that they're the same, as we've talked about before. Number 8, we've got square root of 6, or negative square root of 6, minus the square root of 24. You could break down 6 into 2 and 3, but those are both prime pairs to match up with. So for 24, it doesn't matter which route you go, but I'm going to go, let's go 2 and 12, just for a little different look. So far, nothing, but I can break down 12 into a couple different options. We could go, let's go 4 and 3. All right. So I could go ahead and break down the square root of 4, but I do know that this comes out to 2. So on the outside, I'll have a 2, and then these two guys, square root of 2 and square root of 3, don't have any partners. So here's what we've got overall. Kind of rewrite this. I've got negative square root of 6 minus, and I'll go 2 times square root of 2 times square root of 3. And then I can combine these two, and that will give us a square root of 6. So we've actually got negative square root of 6 minus 2 square root of 6. And what do we got? We do have some like terms, square root of 6 and square root of 6. There's a 1 there, so really we've got negative 1 minus 2, which is negative 3, and square root of 6. So that would be my final answer for number 8. That was a little interesting. All right, so that does it for our addition, subtraction. Now we're on multiplication, my favorite. I don't know why I like it so much, but I do. Let's look here what we got. So you've got two options with multiplication. You can combine these two right away. Since we're multiplying, you can multiply anything together that you want to with square roots. So you could rewrite this as negative 4 square root of 200 by taking 20 times 10, and then break down 200. Your other option, which is usually the route that I take, is I break them down separately and then look at any pairings that I can find within those. So square root of 20, we've already kind of worked with this one. We have twice already. And then 10, I'm going to go square root of 2 and square root of 5. Okay. And now that we have everything kind of laid out, again, you can look at your square root of 4. You know the square root of 4, so you can go ahead and just call that 2 if you would like. Or if you break things down all the way, you can do that, match up your pairs, which is something you can always do. And then you'll also want to look at if there are any extra pairs or anything like that. So for instance, I do have a square root of 5 and a square root of 5 that I can pair up together. Those give me a 5. So it'd kind of be like if I reordered everything. I could go square root of 4 times square root of 5 times square root of 5 times square root of 2, just taking all of this stuff and rearranging it. And then these two together would be square root of 25, which just gets us right back here at 5. So just some things that you can think about, visualize, but shortcuts, since everything's being multiplied together there, we can just say that that's going to come out to 5 whenever we have a pair of square roots. So here's what we got on the outside. We have negative 4 times 2 times 5. And then what we got left, we have a square root of 2. So negative 4 times 2 is 8 times 5 is negative 40. So negative 40 square root of 2 is your final answer. All right. Now, some of you may have preferred to do it that other way that I had mentioned in the beginning, where these two together give you the square root of 200. And if you break this down into square root of 100 times the square root of 2, you know what the square root of 100 is, it's 10. So this is on the outside, 10 times negative 4 is negative 40, left over square root of 2, and we get the same answer. Now there are a number of different ways to get to that conclusion, but that's another option. So sometimes it's easier to combine them, sometimes it's easier to just break things down as they are and look for your pairs after the fact. 6 and get that. So that's going to come out to 72. And then x to the second times x to the third is x to the fifth. And now all of this is underneath the square root. So you can go that route and start breaking that down if you want to. I'll just continue with this since this is what I am showing you currently. So I'll go square root of 8 times the square root of 9. You know the square root of 9 is 3. And we'll break this down into 2 and 4. And you know the square root of 4 is 2. So on the outside, I've got 2 and 3. And then you also have your x to the fifth underneath the square root. So what I'm going to do with this, I'm going to split this up into x to the fourth times x to the first. And you could split up x to the fourth into x squared and x squared because with our exponents, remember when you're multiplying things with the same base, you can add together your exponents. So that is why we can do that. Now this is a pair, so this is really coming out as x to the second. Now, kind of the cool thing though is whenever you have an even power, a square root is just going to half that thing. So if you see the square root of an even, you can just say, oh, half of that is 2, and we get x squared. So now all this stuff is on the outside. So we have 2 times 3, which is 6, x to the squared, x squared on the outside, and then on the inside still we have a 2 and an x to the first. So 2x would be left over. Oops, I just totally messed up my window there. So 6 should be up here. So 6x squared times the square root of 2x. Not the only way you could get there. You could have started separating things as they were from the beginning. I don't have a ton of time left in my video, so I'm going to leave it, but you could have gotten to that in a different way. Same thing with 14. I'll do this one a little bit differently, just to show you the other options you have. If you want to right away, you know, -2 and -5 are on the outside, or +5, sorry, are on the outside. Let's break down 8 into 4 and 2. You know the square root of 4 is 2. So we could add another 2 up here. So took care of that. R to the third, you can split up into R to the second times R to the first. Square root of R to the second is just R. So now this is on the outside as well. And then square root of 6. 6 breaks down into 2 and 3, but that's all the further you can take it. So that's going to be on the inside, square root of 6. And the square root, again, of R to the second is just R. So we also have R times R on the outside. And what do we have left on the inside? We have an R and a square root of 6. So here's what we got total. -2 times 5 is -10 times 2 is -20. And R times R is R to the second, square root of 6R. So kind of a long one there. All right, moving on to division real quick. Remember, we don't want any square roots in the denominator, so let's see if we can get rid of some stuff here. This breaks down into square root of 2 times the square root of 9.